Starting with lecture number 13. It's about composite functions and some special issues related with that. Let me take a function fx equals to x square. Let me take a function gx equals to 2x plus 3. What I can do is that I can write the inverse of fx, that would be root of x, inverse of g, that will come out to be x minus 3 divided by 2. And let me form different kind of functions. I can form, for example, I'll just reduce the brightness, f of gx. That means gx will be inside fx. So fx is x square. So f of gx would be gx the whole thing square, which is 2x plus 3 whole square. Similarly, I can evaluate g of fx. What does it mean? Fx inside g. Fx is x square, gx is 2x plus 3. That would be 2 times fx plus 3. That would be 2 times x square plus 3. Similarly, what I can do is that I can evaluate f of fx and I can evaluate g of gx. So f of fx, that means fx the whole thing square, which is x square, that is x raised to power of 4. Similarly, g of gx would be 2 times gx plus 3. That would be 2 times 2x plus 3 plus 3. That would be 4x plus 6 plus 3, which is 4x plus 9. Let me shift this a bit down. Okay, what else can be formed? Something like f of g inverse x and f inverse of gx. And of course, you can have many more options. Something like g of f inverse x and g inverse of fx. So f of g inverse, that means fx is x square. So therefore this is g inverse x the whole thing square. What is g inverse? X minus 3 divided by 2 the whole thing square. F inverse of gx, f inverse is root x, that is root of gx, that is root of 2x plus 3. Similarly, g of f inverse, gx is 2x plus 3, so therefore this is 2 times f inverse x plus 3. Let me write x over here. That is 2 root x plus 3. And similarly, g inverse of fx, what is g inverse? X minus 3 over 2, which is fx minus 3 divided by 2, which is x square minus 3 over 2. So a lot of possible scenarios are there. These two were the original ones. Let me highlight them. Fx and gx. These two were its inverse. And then we formed f of g and g of f and f of f and g of g, f of g inverse, f inverse of g, g of f inverse, g inverse of f. There are two more which I can form, but there is no use. F of f inverse x is always x. It's a hard and fast rule. G of g inverse x is also x. F inverse of f is also x. G inverse of g is also x. So these two are hard and fast rule which we can always take for granted. This is a hard and fast rule. This is something to do with a function and its inverse. When we take out its composite in any order is always equals to x. Now, based upon this, let's look at these questions. These are add maths questions, by the way, but they are very important because anything out of add maths can come in P1, anything out of P1 can go in add maths. The functions f and g are defined by such and such. Fx is this much and gx is this much. Express each of the following as a composite function using only f, g, f inverse or g inverse. Now, basically for 1 mark, 1 mark, 1 mark, you have to judge how initially was it formed. So I'm just writing it down. Fx is x cube. In other words, f inverse x is cube root of x. Gx is x plus 2. Therefore, g inverse would be subtraction of 2. These are the 4 basics one. Now, x cube plus 2, basically you have something like this and this x is replaced with x cube. Got the idea? So now the first thing is this x is replaced with this x cube. In other words, instead of x you are putting in fx. So let me write it down. It's kind of trial and error, educated trial and error. G of fx is basically fx plus 2. You don't have to give any rationale. Just writing this will earn you that 1 mark, but I'm making the examiner more than happy. So fx is x cube plus 2. That means my working is correct. I have checked my working before the examiner actually checks it. The next one, x cube minus 2. Now this minus is over here and again x is replaced with x cube and x cube is fx. So this time what is the correct one? Let me write it again. So therefore this looks like g inverse of fx, which is fx minus 2, which is x cube minus 2. Again this is correct. The last one is x plus 2 cube root. This 1/3 is cube root. That means this cube root is at the top. So basically it's a function of f inverse, and what is being plugged in instead of x, it's x plus 2. So it looks like this is f inverse of gx. So the third one looks like f inverse of gx. Therefore f inverse is cube root of something and gx is gx and gx is x plus 2. So this is cube root of x plus 2. Again this is correct. Let me do some more. The functions f and g are defined by such and such. The first one is easy, ignore that. I'm focusing on part B. The functions f and g, h and k are defined as hx is equals to x plus 4. Therefore, h inverse x would be x minus 4. Kx is equals to square root of x. Therefore, k inverse x would be square of x. The functions h and x are defined by such and such. Express each of the following in terms of h and k. First part is the function is x plus 4 square root. So square root is kx and x plus 4 is x. So it seems like this is k of hx, which is square root of hx, which is square root of x plus 4, and that is the correct answer. Second part, x plus 8. Now 8 is related with 4. Looks like h of hx. Therefore, this is x plus 4, that is hx. So therefore this is hx plus 4, which is x plus 4 plus 4, which is x plus 8. This is also correct. Third one is x square minus 4. Third one is x square minus 4. So now minus 4 is because of h inverse and x square is because of this. So x square is being inserted over here. In other words, this looks like h inverse, k inverse. There is no harm in writing it. H inverse is x minus 4, and this is k inverse x minus 4, which is x square minus 4. So this is also correct. The third question, just like this. The functions g, h, and k are defined as such and such. I think the k is not used over here. That's why I have omitted it. I hope so. There is no mistake. Gx is 1 over x plus 5, and x should not equal to negative 5. Acha, kx is written over there, my bad. Hx is equals to x square minus 1, and kx is 2x plus 1. It was all written in a line, so that's why it was kind of blurry. Expressed in terms of such and such. So first of all, at the part 1, that is 1 over x square minus 1 plus 5. So this x square minus 1 is basically this thing. It's being replaced over here. So gx, you are inserting x square minus 1. So this looks like g of hx, double check, 1 over hx plus 5. What is hx? Hx is 1 over x square minus 1 plus 5. So this is perfectly right. Second one, 2 over x plus 5 plus 1. So this 2 and this 1 seems from here. So therefore, part 2 is kx. You are inserting gx inside kx. So k of gx, that is 2 times gx plus 1. And this is 2 times gx is 1 over x plus 5 plus 1, and it's all correct. So these were some of the questions. Now this one, this is a P1 question. What does it say? Express 4x square plus 12x plus 10 in this particular form. So first part is almost completing square method. Let me first do the completing square, and then I'll take care of the indices. This is x square plus 3x plus 10 over 4. 4 as it is, x square plus 3x plus bracket square minus bracket square, 10 over 4, let it remain as 10 over 4. What goes inside the bracket? 3 over 2, 3 over 2. Rewrite the first 3 terms as a perfect square. So this is 4, this is something, minus 9 over 4 plus 10 over 4. What becomes of this? This is x plus 3 over 2 whole square. And then let's open up the bracket. This is 4x plus 3 over 2 whole square. Minus 9 plus 10 is plus 1. So this is 1/4. 1/4 into 4 is plus 1. This is the completing square method. Ax minus h whole square plus k. This is the completing square method, and we use it for sketching purposes. We use it for finding the expression of f inverse. Now what does it say? They are saying that a should be inside. The coefficient of x should be a constant a. What should I do? So now write 4 as 2 square and apply rules of indices. Which rule of indices are we interested in? A power m, b power m, that is ab power m. So therefore this is 2 square. This is x plus 3 over 2 whole square plus 1. That is 2 bracket x plus 3 over 2, the whole thing square plus 1. That is 2x plus 3, the whole thing square plus 1. So now it's in that form, which is ax plus b whole square plus c. Is that so? Yes, it is. Now it says functions f and g. I'm interested in the composite, so I'll just stop till over here. I'm not interested in the other part. Functions f and g are both defined for x is greater than 0. It is given that fx is x squared plus 1 and f of gx is this thing. Find gx. So now let's make a box over here so that everything could be in one place. And let's do the working over here. f of gx, the expanded form was given. Now this is 2x plus 3 whole square plus 1. And f of x is x square plus 1. F of x is x square plus 1. Now what have you substituted? So if this is x, there is square plus 1. If this is gx, that means this is gx. So it's just by observation. Therefore, gx is 2x plus 3. And you can always double check. Now let's look at this question. This is not a composite question. This is a different one. So let's try this question out. So this was out of the blue that came. A trial and error is needed for the range of this particular thing. Functions f and g are defined by such and such. Fx is 1 over x square minus 9. And gx is equals to 2x minus 3. And find and simplify an expression for g of gx. The first part is easy. G of gx, that is 2 times gx minus 3, that is 2 times 2x minus 3 minus 3, that is 4x minus 6 minus 3, that is 4x minus 9. That is just basic stuff. Let's also do part 3. Part 3 is f of g of x is 1 over 7. F of g of x is 1 over 7. Simple equation. So f of x is 1 over x squared plus 9 minus 9. Therefore, f of gx is 1 over gx whole square minus 9 is equals to 1 over 7. But gx is 2x minus 3. So 1 over 2x minus 3, the whole thing square minus 9 is 1 over 7. So in other words, 2x minus 3, the whole thing square minus 9 is equals to 7. 2x minus 3, the whole thing square is 16. 2x minus 3 is equals to plus minus 4. 2x minus 3 is equals to positive 4. 2x minus 3 equals to negative 4. Choose the value that would lie within this range. So therefore, 2x equals to 7. Therefore, x is 7 over 2. 2x minus 3 is minus 4 plus 3 is negative 1. X is negative half. So therefore, accept this thing. Therefore, reject this thing. Let's look at the very last answer, which unfortunately is not written over here. Now, let's move on to this part. That's the second part. Find an expression for f inverse and state the domain of f inverse. Let y is equals to fx. Therefore, f inverse y equals to x. So y is equals to 1 over x square minus 9. X square minus 9 equals to 1 over y. X square is equals to 1 over y plus 9. X is equals to square root of 1 over y plus 9. But remember, x is equals to f inverse of y. So therefore, f inverse of y is equals to 1 over y plus 9 square root, or fx equals to 1 over x plus 9 square root. Now there is another thing that some people might have missed. That is, whenever you take a square root, there is a positive or a negative sign. Now since domain of the function is to the right of turning point, we don't know whether that's a turning point or not, because we can't sketch it. So don't think that much further. Just by default give it a positive sign. If it was a quadratic function, right of turning point is positive, left of turning point is negative. So that's not the issue over here. One other issue, domain of f inverse, we don't know how to sketch this. We don't know how to sketch the original one. So there would be some trial and error. Domain of f inverse is the same thing as range of fx. Now let's focus on fx. 1 over x square minus 9. So let me add a page. Yeah, I can just do it on the side. 1 over x square minus 9. This is not the usual reciprocal function. A over x minus h raised to power of n plus k. We have drawn n is equals to 1. We have drawn n is equals to 2. Unfortunately, this does not belong in this category. So this does not belong in this category. So how should I do it? When it says x is greater than 3, that means the domain Sx lies between 3 and infinity. Let me plug in infinity. F of infinity, that is 1 over infinity square minus 9. We know that infinity square is still infinity, minus 9 is still infinity. 1 divided by infinity is actually 0. So this is one value that you get. Let me choose another value. Let me choose 3, for example. If I choose 3, 1 over, of course I should not because it's greater than 3. So this is 3 square minus 9. That comes out to be 1 over 0, which is infinity. That's another thing that we get. If I choose 4, for example, that is 1 over 4 square minus 9, which is 16 minus 9, which is 7. If I choose 5, what happens is that 1 over 5 square minus 9, 25 minus 9 is 16. That means if I do the analysis, the numbers are getting smaller. So 3 is giving me infinity, and 4 is giving me 1 over 7, and 5 is giving me 1 over 16, and dot 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 infinity is giving me 0. Got the idea? Therefore, this is not inclusive. This is not inclusive. Neither you reach infinity nor is 3 included. Therefore, the range of fx is fx lies between infinity and 0, or I can say fx is greater than 0. And range of fx is the same thing as domain of f inverse. We know that. Therefore, domain of f inverse is x is greater than 0, or x lies between 0 and infinity, and that is the answer for this particular part. So that completes lecture number 13 of functions, and one more lecture is left. Stay tuned, and that will be on trigonometric functions.